Hello everyone and welcome to another Maths Challenge question. Let's have a read of it together. So we have a quarter circle PRT, so that's PRT, this one here. It is removed from a quarter circle OQS, this big one here, to leave three shaded regions as shown. So this one, and this one. OPRT, so OPRT, this square here, it's a square, and OP equals 2x here. What is the total area of the three shaded regions? You can have a pause of the video and go through it yourself, then unpause the video and check out the method. So when I see this question, first of all, I immediately want to redraw it. That way I can label any information that I know. So let's redraw it. I'm not an artist, so don't say anything about my artwork. And let's put in some of the information that we know. So we know OP equals 2x. I think that's helpful to put in here. 2x. Okay, now since OPRT is a square, then we also know that OT, RT, and PR are also 2x in length. So let's put those in. Okay, now that's really useful because that means that this quarter circle here, the radius, if it was a full circle, would be 2x. Okay, that's very good because we can find out areas of quarter circles using the formula for the area of a circle. So area of a circle, the formula for that is pi r squared. Cool. Therefore, what is the area of a quarter circle going to be? Let's write that down here. Area of a quarter circle, that's just going to be pi r squared over 4. Cool. So let's find out the area of this shape first of all. So the radius is 2x. Therefore, the area, let's call this shape here A. So the area of A equals pi lots of r squared, where r is the radius, 2x. And let's just simplify that a little bit. So when we square this 2x, we're going to get a 4x squared, and we're dividing by 4. So we're going to be left with pi x squared. Cool. So we've found the area so far of PRT, this quarter circle. Now let's find the area of this big quarter circle, because then we can subtract this quarter circle area from this big quarter circle area to find the area of the shaded regions. Now the problem with that is we need to know the radius of this quarter circle, which is a bit harder. Okay, but I've noticed something a little bit interesting. It's hard to find the radius here. But remember that the radius is also equal to this length here. Since this is the center of our big circle, and this is on the circumference of our big circle. So if we were to find this length here, we would have the radius. Well, I can see that I can make a right-angled triangle. This right-angled triangle here, where the length of the base is 2x, the length of the height is 2x, and I can use Pythagoras' theorem to get the hypotenuse. So, using Pythagoras' theorem, let's do 2x squared plus 2x squared. Okay, 2x squared is 4x squared. Add those together, we get 8x squared. Then we just need to do the square root of that value. So the square root of 8x squared, which we can simplify to root 8x. And if we want, we can convert that to 2 root 2x. Cool. So now we've got the radius of the big circle. Now that we've got the radius, we can use the formula for the area of a quarter circle. Cool. So let's do area of B. That's going to be my big quarter circle. So that's going to be pi lots of r squared. So remember, r is this value here. We know that r squared is just going to be 8x squared. So we're going to just put that in. And then all over 4. Now we just need to simplify this. 8 divided by 4 is 2, so we're going to get 2 pi x squared. Now what we have to do is subtract these areas from each other to get the area of the shaded region. So we need to do the big quarter circle minus the smaller quarter circle. So we have 2 pi x squared minus pi x squared, and that just leaves us with pi x squared. Cool. Now, is that a value? Yes, that's one of the solutions here, pi x squared. So E is our answer, and we're done. If you want to try more problems like this one, then have a check of the other videos that I have.